India has crossed a critical threshold in the race of hypersonic weapons. The Defense Research and Development Laboratory, a key laboratory of the Defense Research and Development Organization, has successfully conducted a long-duration ground test of actively cooled scramjet full-scale combustion. The test was conducted on January 9th of 2026 at DRDL's Advanced Scramjet Connect Pipe Test Facility, achieving a sustained runtime of over 12 minutes, a landmark achievement in hypersonic propulsion. This milestone quietly moves India closer to operational hypersonic missiles, the weapons that can travel at more than 5 times the speed of sound. But what exactly did India test, and why does it matter so much?
To understand the importance of this breakthrough, we need to understand the engine at its heart, the scramjet. A scramjet, or a supersonic combustion ramjet, is fundamentally different from conventional jet engines. Unlike turbojets or rockets, a scramjet has no moving parts, draws oxygen directly from the atmosphere, burns fuel while air flows through the engine, remains supersonic. During the DRDL test, the combustion was actively cooled, a critical requirement because temperature at hypersonic speeds can exceed more than 1000 degrees Celsius. This can lead to equipment failure. Sustaining combustion for 12 minutes demonstrates that India has solved one of the hardest challenges in hypersonic flight, and that is thermal management and stable combustion at extreme speeds.
Scramjets are often confused with ramjets. Why are they different and why do they matter? I'll explain to you with the help of these diagrams on the video wall. This is a ramjet and over there is a scramjet. The basic difference is that ramjet propels the missile from Mach 3 to Mach 5, that is 3 times faster than the speed of sound to 5 times faster than the speed of sound, while the scramjet is a hypersonic engine which propels a missile beyond Mach 5. So this is the basic difference between these two engines. So how do these engines actually function? So let's try and understand. When we talk of ramjet, supersonic air enters the ramjet, it is slowed down, fuel is injected, ignition is carried out, and exhaust propel the missile at supersonic speed. Now here we have a cone in between this engine that you can see. This is the cone that slows down the airflow. The supersonic airflow coming slows down, ignition takes place, and exhausts go out, thus propelling the missile at Mach 3, Mach 5. Now, when we talk of scramjet, in scramjet, the speed of the air is not reduced. The hypersonic speed or the supersonic speed of the air continues to remain in that form. Ignition is carried out, fuel is injected, and the gases coming out are also at the same speed as the intake, that is hypersonic inflow and hypersonic outflow. So this is the basic difference between a scramjet and a ramjet, and that is why scramjet technology is very, very difficult to achieve, because it is something like in a hurricane you are trying to light a candle. So the airflow is hypersonic, you are carrying out ignition, which is the most toughest part, while in a ramjet it is not so, because you are slowing down the airflow, giving ignition, and then propelling the missile at the desired speed. So this is the basic difference between these two engines. Apart from this, people also confuse between a hypersonic glide vehicle and a hypersonic missile. So how is a hypersonic missile different from that of a hypersonic glide vehicle? This is a fantastic video wall that has been prepared by the team, which will explain to you the difference between a ballistic missile, a hypersonic glide vehicle, and a hypersonic cruise missile. So what we see here is a launch site and the target and the parabola where ballistic missile is written, and we have India's Agni missile. So this is the parabola of the ballistic missile. Ballistic missile is fired, it crosses the atmosphere into space, travels in space, does a re-entry and hits the target. Now let's talk about hypersonic glide vehicle. Hypersonic glide vehicle is mounted on a ballistic missile. So it is fired like a ballistic missile. It fires, it crosses the atmosphere, goes into space, and when it is on the top, points towards the target and releases the hypersonic glide vehicle. The hypersonic glide vehicle, because of the potential and the kinetic energy already achieved, it glides down, it accelerates further and hits the target. Now when we talk of hypersonic cruise missile, it is fired, it does not cross the Earth's atmosphere. It stays anywhere between 20 to 30 kilometers, travels along the Earth, basically parallel, and then hits the target. Now both the hypersonic glide vehicle is also maneuverable, but then it is gliding, it is not maneuverable to that extent, while that the hypersonic cruise missile is totally maneuverable like any other cruise missile. So this is the difference between the ballistic missile, hypersonic glide vehicle, and the hypersonic cruise missile. Having understood the basic differences between a ramjet, scramjet, hypersonic glide vehicle and a hypersonic missile, let's qualify as to what does this DRDL test actually tell us about India's hypersonic roadmap. Why this test is a strategic breakthrough.
Sustaining scramjet combustion for over 12 minutes is a global benchmark achievement as it indicates maturity of indigenous scramjet design, readiness to transition from laboratory tests to flight trials, and a strong foundation for long-range maneuverable hypersonic strike weapons. Only a handful of nations, including the United States, China, and Russia, have demonstrated comparable capabilities. For India, this test signals a shift from experimental hypersonics to weapon-grade systems.
This scramjet breakthrough is not just about speed, it's about strategic credibility. Hypersonic cruise missiles powered by scramjet compresses decision-making timelines, thus evade existing missile defenses and redefine deterrence. With DRDL's successful long-duration test, India has taken a decisive step into that elite club.